You know the situation. Now to solve that problem, we are using one solution called a critical section. Okay, you are providing one solution. ROS is providing one solution that is referred as critical section. We will see what is critical section. Okay. So whenever a process, producer process or consumer process is considered, we are having three stages. One is entry stage, then one is entering into the critical section stage, then exiting from critical section, then do remainder section. That means, listen carefully. So process P1 is there. Okay, process P1 is there. Any process work can be divided into two sections. One is remainder section, another one is critical section. Okay. So critical section means a process is accessing shared variables. Okay, critical section part means the lines in the program that accessing sensitive variables or shared variables. Okay, a project before entering into critical section, we have to get permission from the operating system. Okay, that is entry. After using the critical section, we have to inform OS that I have completed my work. Then you can do the remainder section. Okay, listen, one small example I am telling. So first program is normal. First line is normal line. Second line is normal line. Third line needs some counter value. Counter variable means what? Shared variable. That is common variable. Fourth line also needs counter value. Fifth line doesn't need any data. Sixth doesn't need anything. Seventh line again it needs a counter value. Now what will happen? First, program will execute in remainder section for these two lines. After that, program will ask operating system permission for critical section. If permission is granted, these two lines will be executed in critical section. After that, it will inform OS my work is over. Then again 5 and 6 will be done in remainder section. Then 7 will be using critical section. Then 8, 9, 10 will be doing remainder section. Okay, so to say it simply what? Whenever you are accessing shared variable or common variable, you need permission from the operating system to get the access. Okay, so this solution should satisfy three conditions. Then only we can say that counter value is safe for both the producer and the consumer process. Okay, so what are the three conditions to be satisfied for critical section problem? One is mutual exclusion. Okay, just listen carefully. What do you mean by mutual exclusion? When one process, okay, when one process is executing in its critical section, listen carefully. This process is executing in its critical section. Process P2 is not allowed to enter into its critical section. It's not allowed to enter into its critical section. That is mutual exclusion. That means what? Either P1 or P2 only can use the critical section. That means what? Both P1 and P2 cannot access critical section in parallel. Okay, what is the problem of synchronization? Concurrent execution. They are executing in parallel. Now we are restricting it. Okay, we are not allowing both P1 and P2 to access or to enter into critical section in parallel. Either P1 should use or P2 should use. For that only we are telling before entering, get permission from OS. So we have to make a request to the OS. I want to use the common variable counter. Then OS will see all the things and he will not allow two programs accessing it in parallel. So he will form a algorithm. OS will form an algorithm. Based on that, first it will allot P1, then it will allot P2, then P3, then P1, then P4, then P5, like that. One by one it will allocate. Okay, that is mutual exclusion. Okay. Another second condition is progress. Suppose P1 wants critical section. Okay. P2 wants critical section. P3 wants critical section, but at the same time, P3 is working in remainder section. Okay, P3 is working in remainder section. Now, these three processes are requesting. Operating system says to P3, don't request a critical section when you are doing some work. Okay, P3 is having work already in remainder section. So P3 should not be allowed for completing the critical section. That means what? A process is not allowed to request a critical section if it is working in remainder section. So who only will be allowed? Whoever not working in remainder section, they wants critical section, they only will be allowed. That means what? Suppose P4 wants critical section and it is not doing any work. Now what does it mean? Competitors for critical section is P1, P2 and P4 only, not P3. Okay, this is what we are referring as progress. Second one is bounded wait. Bounded wait அப்படின்னா P1 is requesting OS for critical section. OS is not granting. Okay, after some time, again P1 is requesting, OS is not granting due to some priority or due to some unavailability, due to some size of the process. Many reasons are there. Okay. After some time, P1 is requesting OS is not allowing. What we are trying to say is, don't put any process to wait for a long time. Okay, so that means what? Operating system should not allow any process to wait for unbounded time. Okay, endless waiting. There should not be any endless waiting. That means what? Suppose, for example, when P1 is requesting the OS will mark some value called 10 for P1. It is not giving the critical section, correct? Not giving the critical section, it will mark one value for 10. Okay. Next time P1 is requesting, now also OS is not allowing, but it is reducing the value to 9. Next also P1 is requesting, not allowing, so it is reduced to value is reduced to 8. Like that, for each request, the value will be reduced by 1. Finally, that value will become 0. Now OS will have no other chance to other than allocating this process. Okay, that means what? There should be a fixed time for waiting. Wait at one stage, surely P1 will get to the critical section. Okay.